Hello there and welcome back to another video. In today's video, I've got plans to reuse some of the parts that came in my Dell R720 server to upgrade the transfer speeds between my NAS and my two main computers. Specifically, I'm planning to reuse these three 8 gigabit per second dual port SFP Plus cards that happen to come with this server. I have no need for them in the server, but I've come up with an idea for how I can use them in my NAS, main PC, and video editing PC. So here's the plan. I'm thinking of putting one of these Logic cards in the NAS and one in either PC. I'll then use one of the ports on the card in the NAS to link directly to one of the ports on the card in my main PC, and then I'll use the other port on the card in the NAS to directly connect to one of the ports on the card that will be in the editing PC. This should allow for 8 gigabit per second transfer speeds between the NAS and either of the PCs, which will be a lot faster than the 2.5 gigabit per second infrastructure that is currently in use. Now, I got these cards included with the server, but of course they didn't come with any cables to connect them to each other. They came with some Finisar FTLF8528P3BCV-QL fiber optic transceivers, and these transceivers are pretty much perfect for this use case, as they're all Q-Logic transceivers, and they're also all identical, so we shouldn't run into any weird compatibility issues. But first, to double check that, and to also find the right fiber cables to buy, I had a glance at their datasheet. After taking a look at several of the key specifications of these transceivers, I settled on these cables from fs.com. They're LC-UPC to LC-UPC duplex, OM3 50/125 multi-mode, 5 meter long cables. I bought these ones from fs.com because they were really inexpensive, being only about $8 a cable before shipping, which isn't too bad in my opinion. So, with the basic plan laid out and all of the necessary hardware acquired, it's time to get to testing these cards out. The first step is to make sure that these cards will recognize in a desktop system. Since I'll be using two of them on standard desktop computers, Windows 10 is going to need to be able to work with them. And really, this is something that should be tested before buying cables. However, I just ended up doing this in a slightly different order than maybe would have been ideal. To test out these cards, I pulled out my Optiplex 7010 testbed system because I didn't want to mess with my mission critical systems right out of the gate. With one of the cards installed in the system, I pressed the power button and was greeted with a power but no post situation and an error code displayed through the power button. These are enterprise cards, and sometimes enterprise cards can be weird with consumer desktop systems. I know that this system works without the card, as is visible right now after taking the card out and booting up again, so what's up? It turns out that I just managed to fail at installing a PCI Express card, and all it needed was a reseat. We're all susceptible to making these simple mistakes, always try the simple things first. With a new installation of Windows 10 set up, I went onto Dell's website to find the drivers for these cards as they came in a Dell server. Getting the drivers installed was actually incredibly seamless, which surprised me massively. I expected these drivers to fight back a lot more when being installed in a Windows 10 desktop system, but I'm not going to complain. However, once the drivers were installed, I noticed that the cards appeared in Device Manager as Q-Logic Fibre Channel adapters. That's not all too weird in and of itself, but what was weird is that these Fibre Channel adapters were under the Storage Controllers section of Device Manager. Something isn't quite behaving as I'd expected here, so I went ahead and opened the Q-Converge Console CLI application, which was installed along with the device drivers. I decided to select the Adapter Configuration option to see if I could configure anything such as the IP and subnet mask for these cards. Now, the people watching this video who are experienced in enterprise standards and hardware know what's up here, but as I've mentioned in previous videos, I don't work in IT and never have. Therefore, I don't have any experience with enterprise hardware and enterprise standards. I had done a reasonable amount of reading up on these adapters before embarking on this project, mainly surrounding their PCI Express connectivity to make sure all my systems had enough lanes to go around. However, there was one big assumption I made when I first saw these cards, which wormed its way all the way to the point where we are now. Even though there were many big, genuinely embarrassing to have missed flags telling me that these are not network cards, I still believed that these were just network cards. If you watched my previous video on the R720 server, I mentioned that these cards are fiber channel cards. I didn't realize this when I was trying to do this project, and I only realized this after getting to the point I'm at now, where these cards aren't acting like network cards. I did all of this before I scripted the R720 video, so I was able to get the information on these cards correct then, but I had to learn what these cards were the hard way, and we're doing that right now. Fibre Channel is a different protocol than Ethernet is, and therefore, these cards cannot do Ethernet connectivity at all. These cards are host bus adapters, or HBAs, which are usually used to connect drives to computers. My desire to use these cards to connect between a file server and computers isn't too far off from what they're actually intended to do, but due to the way that my infrastructure is set up, I can't use Fibre Channel, and sadly, that means that these cards aren't going to work. Well, that sure sucks. These cards aren't going to do what I wanted them to do, which, to be abundantly clear, is entirely my fault for managing to dodge every single indication that they're HBAs, but it's still a shame. I was pretty excited to have a faster link between my main systems and my NAS, especially because I move very large and very sequential files between all three of the systems I plan to connect nearly every day. Now, I'm only a small bit of money into this project, as all I had to buy was the fiber optic cables, which were cheap. I could have abandoned it at this point, but I instead decided to look on eBay and check whether or not 10 gigabit per second SFP Plus Ethernet cards were reasonably priced. That's when I found these HPE 530 SFP Plus dual port 10 gigabit per second Ethernet cards, which are based around the Broadcom/QLogic BCM 57810 chipset. They also came with matching SFP Plus transceivers, all for $15 a card. Anyway, reluctant to give up on my dream of faster networking for my NAS at this point, I bought 3 of them and got to work setting this network up, with the right hardware for the job this time. The first system to get one of these cards was going to be the NAS itself, which is currently an Optiplex 7010, just like the testbed system. I added the new HP network card into the system alongside the existing 2.5 gigabit card. I'm keeping the 2.5 gig card installed because the 10 gig card is only for direct link between my 2 main desktop systems. The 2.5 gig card is still required for access to the NAS from any other device on the network, and so it's going to be staying for the time being. Next, it was time to install the network cards in the desktop systems, and I chose to begin with the video editing workstation before getting the other one installed in my main desktop computer. These network cards are PCI Express 2.0 x8 cards, which is a very important thing to look out for when buying older enterprise gear like this. It's not unlikely that you'll end up with cards from a very old PCI Express revision, which will require a lot more lanes for the same bandwidth as a newer card would. The motherboards in both of my desktop computers have a couple of PCI Express slots, the main important ones being the X16 and 2 X4 slots. Because I have graphics cards in the X16 slots, that means that the 10 gig card will have to run in one of the X4 slots, and therefore it will run at 2.0 by 4. Because of that, it will only have a theoretical maximum of 16 gigatransfers per second of duplex throughput available to it. In the case of these two desktops, that's no issue, as I'm only populating one port on the card, and this 2.0 X4 link is enough to keep up with that. However, if I plan to saturate both 10 gigabit per second ports, this PCI Express link bandwidth would become a bottleneck and limit transfer rates. Now that the NAS and one of the computers were set up with their network cards, I was ready to connect the systems and begin the configuration. I quickly got the systems connected with the fiber optic cable, and it was time to start configuring. I use Open Media Vault on my NAS, which is arguably not the most versatile or feature-packed NAS OS. However, when I built the NAS, it was the only NAS OS that I understood how to configure, and since it's lightweight, it's also the right fit for my NAS with its 3rd gen i7. In any case, the major concern with this was whether or not I'd need to go out of my way to get the BCM 57810 based network card to work. But, a bit to my surprise, the card recognized immediately and showed up with no additional action necessary. I didn't have to go out of my way to find drivers and get them installed in the system, or do any weird things to make the card show up. The next steps were pretty simple, though it took a few tries to get everything communicating correctly. I'm honestly not entirely sure why there were a few issues originally, and what got them all fixed, but after being sufficiently confused for a while, I got it all working, and this is what the final configuration looks like. The 2.5 gig port was given an IP on the 10.0.0.x network, which is the main LAN network. Then, one port on the 10 gig card was given the IP of 10.0.1.1, and the other port was given the IP of 10.0.2.1. Next, on the desktop computers, the computer that was connected to the port of the NAS with the 10.0.1.1 address had its 10 gig port's IP set to 10.0.1.2. And I then mapped the network locations in File Explorer by typing in / 10.0.1.1 / folder name. After configuring the network locations like this, the computer accessed the network shares through the 10 gig card without any issues. I did the exact same on the other system, that is, after installing its network card and getting it all all plugged in, but its IP was 10.0.2.2. All of these IPs were using the subnet mask of 255.255.255.0, by the way. I'm not going to claim to know much of anything about the actual protocols that make the internet tick, as I'm still learning, so I'm sure something here is set up in a slightly suboptimal way, but it's getting me the functionality that I'm looking for, which is all that really matters. And on the topic of said functionality, this is what I could do after it was all set up. I could access the NAS's web UI through any of the 3 IPs it was able to communicate through, though I could only communicate through the 10.0.1.1 and 10.0.2.1 IPs when using my main and editing desktop systems, as those IPs aren't available to the rest of the network. Lastly, I could access all of my shares through all of the other IPs, again with the same access limitations on the 10 gig IPs because they don't connect to the rest of the LAN. So, now that everything is seemingly set up correctly, let's give it a performance test. Copying a video file from my computer to the NAS worked incredibly well, transferring at about 1.08 gigabytes per second, which is very close to the maximum speed you can expect to get out of a 10 gigabit connection. Now, this is only writing this fast because it's currently being cached in the NAS's RAM, and once the RAM in the NAS runs out, it'll drop off significantly as it begins to have to write directly to the disks. However, the test right now is not supposed to be of the NAS's performance and limitations, but rather whether or not these 10 gigabit per second connections are actually passing 10 gigabits per second of traffic, which they seemingly can, at least when writing to the NAS. When reading from the NAS, assuming the file has not been read recently and therefore isn't cached in RAM, it's limited by the disks to about 250 to 300 megabytes a second. However, when reading a cached file, it'll read it off the NAS at 10 gigabits per second all day long. That is, if the cache can last all day, which at these speeds it most certainly cannot. Now, even though the drives are the limiting factor, and I haven't gotten that much more performance over my previous 2.5 gig connection today, meaning that I won't be getting anything close to 10 gigabits per second with this NAS right now, the important thing to keep in mind is that as my NAS grows, which it will be soon, stay tuned, it'll be able to utilize more and more of that 10 gigabit per second link. Additionally, when the drives are the limit, like they are right now in this case, it's like having the storage devices in my local system rather than on a server that's across the room. Having these storage devices perform almost exactly as they would in my PC while being on a server that's accessible to multiple devices is very convenient. Of course, there is a tiny bit of added latency, but for simple file transfers over a fiber optic LAN connection, it makes no difference. The last things I'd like to mention before finishing this video are the final cost of this setup in the end and also the compatibility of these cards. I paid $15 shipped for each of the 10 gigabit per second cards with matching transceivers. These cards have not been the cause of any compatibility or stability issues for my systems in the past few weeks I've been using them, and therefore can say that if you're looking for cheap 10 gigabit per second SFP Plus cards, these HP 530 SFP Plus cards, based on the BCM 57810, might be a decent option. Of course, do your own research and make your own choice, but I haven't had any major issues with my cards. Lastly, the fiber optic cables were about $15 each after shipping costs and taxes, which means that this entire project totaled to about $75 US. To get 10 gigabit per second networking to 2 systems from my NAS, I feel like I could have done a lot worse. It would have been great to have gotten my originally planned 8 gigabit per second networking for a total of $30 with those old QLogic cards, but it's alright in the end. Remember to read the datasheets more carefully than me, and you won't mistake your hardware for being something other than what it is, like I did. In any case, that's all I have for you today. Hopefully you were able to at least find this video interesting and maybe even learn a thing or two. I hope to see you next time. Goodbye.